Let us look at some questions, some examples. Questions which concern a mercury barometer. Let's look at the first case. In A, it says study the diagram. Study the diagram of a mercury barometer. Study the diagram of a mercury barometer below. And this is how the mercury barometer looks like. Okay, so there is atmospheric pressure here, there is a mercury inside, and this is a dish. The distance from here up to here is 4 centimeters. From here up to here, up to this level, is 74 centimeters. From here up to there is 2 centimeters. And inside there is mercury in the dish. Okay, so maybe before even we go to the question, some questions, supposing somebody asks you the name of this, automatically you would call it Torricellian vacuum. Now let's go to the questions. Roman 1, what is the value of the atmospheric pressure? So which one is the answer? The value for atmospheric pressure. We said atmospheric pressure is the distance between the mercury in the dish and where the mercury level ends. This distance is actually the atmospheric pressure. So our answer is supposed to be 74. From here, from the top of the mercury in the dish up to where the mercury level ends in the tube. So that is a distance of 74. So we shall say atmospheric pressure, which sometimes we use capital H to represent, equals to 74 centimeters. As simple as that. Then Roman 2 is saying, give a reason for your answer. Why do you say atmospheric pressure is that? There are so many readings which are here. 2 centimeters is there, 74 centimeters is there, 4 centimeters is also there. Why do you say it is this? What is the reason for your answer? So our reason is the 74 centimeters is actually the height of the mercury column supported by atmospheric pressure. You know, the height of the mercury column, because it is as the atmospheric pressure presses the liquid here, what happens? The liquid rises. How does it rise? From here where it was up to here. So our reason is the 74 centimeters is actually the height of the mercury column supported by atmospheric pressure. Let's look at the second question related to a mercury barometer. It says, that is part B, describe how a simple barometer can be set up to measure atmospheric pressure. Describe how a simple barometer can be set up to measure atmospheric pressure. So this is how you make a simple barometer. How do you do it? How do you make a simple barometer? You need to get a dish, fill there mercury, then you need a long tube, this tube here. Fill this tube also with the mercury. After filling it with the mercury, then you turn it upside down inside. So there will be mercury in the tube, there will be mercury in the dish. So you fill this one with the mercury, you also fill this one with the mercury. Then you turn the tube upside down. And when you turn it upside down, what are you going to see? Much as you filled here with the mercury, you realize that the mercury will fall. The level of the mercury will fall. To create this vacuum, the mercury is going to fall. And when it falls, you now measure the distance between the mercury in the dish and where this mercury has ended when it was falling. And that distance is measured using a millimeter scale. That distance is the same as atmospheric pressure, which we are using capital H to represent. From here, that is from where the mercury fell. Remember, you fill this tube with the mercury, but the level will fall. until it stops somewhere. Where it stops, you measure from that place up to here using a millimeter scale. So when somebody says, describe how a simple barometer can be set up, how can you make a mercury barometer? And after making it, how do you set it up? And then how do you use it to measure atmospheric pressure? How many marks were given? You can imagine 7 marks. So what did you do? The first thing is you draw the diagram. Draw your diagram and label. This is a mercury, this is a dish, this is atmospheric pressure. You know, here you have the long tube, here you have the scale, and please give us the difference in height from here up to there as the atmospheric pressure in millimeters of mercury or centimeters of mercury, depending on the scale and the units you have used. So as part of the description, you say a long tube 1 meter long, closed at one end, is filled with mercury using a funnel. So you get a long tube which is closed at one end. It must be 1 meter long. You see, a long tube 1 meter long, so the length should be known. And that tube should be closed at one end, is filled with mercury using a funnel. So which tube are we talking about? This is the tube we are talking about, this one. This tube here. This tube. This is the long tube. Fill it with the mercury. After filling it with the mercury, remember that the tube must be 1 meter long. It is closed at one end. You see, a long tube, 1 meter long, closed at one end, is filled with mercury using a funnel. Then after that, over the open end of the tube, remember this tube has 2 ends. Look at this tube. This side is closed, but this side is what? Open. So on the open end, before you invert, before you turn it upside down, you get the tube the way it is, fill it with the mercury. Is that okay? Then at the open end, you put your finger. You close the open end with the finger. And then you invert it so many times. Turn it upside down so many times. That's why we are saying over the open end of the tube, a finger is placed and the tube inverted several times to trap and remove the air bubble. You see? So the reason why you are putting your finger there is to close the mercury so that it does not pour. The reason why you are inverting so many times, you are inverting before you put it in the dish of mercury. You invert it so many times. You keep on doing this, you shake it, keep on inverting so many times. The reason is you are trying to find out if there is any air inside. And if it is there, it should be removed. So the next thing is the tube is then filled with mercury, more mercury. You know, after inverting the tube so many times, maybe there was air inside. So when that air goes away, it will leave some space. So you add more mercury. And then after doing that, you can now turn the tube upside down. You invert it into a dish of mercury. So all these are the things you are supposed to do before you invert it in a dish of mercury. Get your long tube. Your long tube, 1 meter long. It is closed at one end. Fill it with mercury using a funnel. Put your finger over the open end of the tube. A finger is placed and the tube is inverted several times. The reason is to trap and to remove any air bubbles. After the air bubble has been removed, then you fill the tube with more mercury. The tube is then filled with more mercury and inverted in a dish of mercury. Now, after inverting this, after putting it in a dish of mercury, what do you see? Much as you fill this tube with mercury, you'll realize that the mercury level begins falling down until it becomes constant. So under our observation, the first observation is the mercury column falls until the height becomes constant. So the mercury in the tube, in the long tube, will drop until it becomes constant, until it stops. Another thing, so using that observation, you can conclude that the height of mercury column is measured using a scale. Once the mercury column has fallen and it has stopped, what do? You take your millimeter scale, you measure, and then you take the reading. And the reading you are going to take is the same as atmospheric pressure. So the height of the mercury column is measured using a scale and is taken as the atmospheric pressure. We expect that height to be 760 millimeters of mercury.